welcome to Random Acts of Science. I'm Miss Amy at the Grass Valley Library. This week we're going to be studying wind speed and trying to determine how we can measure that. So this week's experiment takes place in two parts. The first part is going to be building an instrument that measures wind speed. That instrument is called an anemometer. And then the second part is going to be actually taking that measurement, calibrating the machine. So we'll talk that through as we go here. If you haven't already picked up a bag at the Grass Valley Library, everything you're going to need for the experiment for the most part is inside of this bag. On the outside, you'll see the QR code. You can scan that with your phone or other device, and it'll take you right to this video on YouTube. You can also find it on Facebook, at least for a week or two after the program. So let's find out what's in today's bag. We've got the instruction sheet for the experiment. This is going to tell you what's in the bag, what you'll need from home in addition to what's in the bag, directions for the experiment. On the back side, you're going to see a picture of what we're building, the anemometer. You'll see a picture of that, and then a little bit more explanation about the science and another resource that you can check out if you want more information after that. Also in the bag, there's 3 wooden dowels. These dowels are generally going to be wrapped in black electrical tape. That tape is something you're also going to need for the experiment. So after you unwrap your dowels, make sure you hang on to that tape because we are going to need it at the end. So I'm going to stick it over here. Got my dowels. Also in the bag, there's a water bottle. When you get it, this water bottle is going to be full. You can go ahead and drink it, water some plants, dump it on the ground, but we're going to need an empty water bottle for the experiment. So you can start drinking now, and then when we get to that point, maybe you'll be out of water. The last thing in the bag are some paper cups. There's 2 different types. We have 4 small cups with the blue design on them, and we have 1 white cup that's a little bit bigger. It's got 4 holes in it. So they are used for different purposes, but we're going to use them all as we build our anemometer. So I'm going to trade out my full water for an empty water bottle in the interest of making this keep moving along here. So let's do the first part of this. Let's build an anemometer. This is a simple machine that weather forecasters, meteorologists, and scientists use to measure wind speed. So they look a lot like this one. This is called a cup anemometer, and some of those are pretty much what's used elsewhere. They have a lot more technology attached to them, so they're a little bit more sophisticated that way. But for our purposes, building a simple one will still teach us how to measure wind speed. So let's do that. So the first thing you want to do is remove the electrical tape, which we did, from your dowels. The second thing that you need to do is insert 2 of the dowels into the big white cup. So this is that biggest cup. You'll see that there's 4 holes in it. That's so 2 of the dowels, or the two dowels can be inserted into it at cross angles from each other. So when they're all together, it's going to look like that. You're making a big X with an X in the middle. Okay, so that is the top part of the anemometer. The next thing you're going to do is thread the cups on there. I'm going to skip ahead just a little bit and do the third step first. I'm going to poke a hole in the bottom of the cup with a pencil. That's one thing that you will probably need from home. You can just poke it through if you want to, but a pencil is like the perfect size. And then you're going to insert that 3rd dowel in the bottom of it. And the only real tricky part of this is taping it all together so that it all stays together and moves together. So the easiest way that I've found is to push that dowel up a little bit higher through the top, about an inch or so above the bottom of the dowel. You're going to want to wrap some tape around that. And once that's pretty sturdy, this, like I said, is the tricky part. Maybe you'll find a better way to do this, but I'm going to stuff it back in there. And then I'm going to wrap it around the other 2 dowels. So I'm just kind of making a big loop with it. It's sticky and tricky, but I think we can do it here. Okay, it took me a second, but I got it. So when you're done, it's gonna look something like that. So it's all gonna move together. This bottom dowel is just gonna come up to the bottom of the dowel, the lowest of the two other dowels. It's gonna come right up into the bottom of that, and then you're gonna wrap it as best you can so it all moves together. Okay, the next part of the experiment is to take the cups and thread them on to the ends of the 4 dowel pieces that we have sticking out. They're gonna hang, so each of these cups has 2 holes in the top, and they're gonna kind of hang from the top of the cup once you thread them on the dowel. So, can you see how that looks? It's just hanging off the top of that, and the dowel is very much at the very top of that cup as much as you can get it there. You're gonna go ahead and do the other ones as well, and then after that, we're almost done. There's 2. And see how the cups are all facing in the same direction? If they're facing back to back, you want to flip them around so they're facing, so all the tops of the cups are facing in the same direction. Okay, so I've got my 4 cups on there. So this is what my anemometer looks like at this point. And when you get to that point, you're just gonna pop it into the water bottle. As you can see, it's gonna spin really easily. If you blow on it, it should start spinning. Like just like that, we got it. Okay, so that's part 1. That's building the anemometer. The second part is calibrating the anemometer. So calibration is when you verify that a machine is accurate enough. So we need to establish like a baseline of how fast this thing is going to spin, so that we can tell how fast the wind is blowing when we're not at that baseline level. So what you want to do is wait for a non-windy day. Wait till it's super still outside, because the wind speed in the air is going to be a variable that we can't really control for, because we don't know how fast it's going yet. So we want to reduce that to 0. So you want to wait until it's a very still and calm day. For this part of the experiment, you're going to have to grab an adult or a caregiver, someone who can drive you in the car, and someone who is willing to help you out with this experiment. The other thing that you're going to need at this point is a stopwatch. You can use the timer on a cell phone. You can use a wall clock if it has a second hand. If you know somebody that has a watch that also has that second hand that's kind of ticking the seconds off, you can use that as well. So our process for, I'm going to talk you through this. I'm not going to take this out into the car with the camera today, but the process for this is getting in the car, finding a nice, pretty straight, safe street, and having the adult drive at 10 miles an hour down the street. You're going to set your stopwatch or your timer or an alarm for 30 seconds. So for 30 seconds, you're going to hold the anemometer out the window of the car, and you are going to let the wind at 10 miles an hour, because that's how we know how fast we're going, 10 miles an hour. And your speedometer on the car is going to be our calibrator. It's going to be the thing that measures how fast we're going. So maybe you might let the adult get it up to 10 miles an hour and then keep it there for 30 seconds before you really start, or don't put this out the window until you're at 10 miles an hour. So when you're ready, you're going to take 1 cup maybe as your counter. This might be a good reason to decorate a cup, put some stickers on it or paint it, or just do something to make one of the cups stand out from all the other cups. And you're going to count how many revolutions, how many times it goes around the center dowel in 30 seconds. So if you keep your eye on that 1 cup, you can get a count at the end of 30 seconds. You might want to do it a couple different times so that you have like a range of data, and you can kind of average that out if you need to. But let's say that it's going 20 miles an hour, or 20, let's say it's revolving 20 times in that 30 seconds, then that's going to be the number that you're going to use when you go and measure wind speed elsewhere. Like if you stick this on the lawn, or it's somewhere else, if you go faster, I guess you could try it that way too. But basically, however many times that revolves at 30 seconds at 10 miles an hour is about the same you're going to find when the wind is blowing 10 miles an hour. So if you put this on, if you do that measurement out the car window and you find that it's going around 20 times in 30 seconds, and you put this on the lawn and it also spins 20 times in 30 seconds, then you've got about a 10 mile an hour wind blowing through your anemometer. If it's double that, if it spins around 40 times in 30 seconds, then your wind speed is doubled and you've got a 20 mile an hour wind. So hopefully that makes sense. You can go ahead and try it yourself, see how it goes. I'd love to hear how it went and if you had a good time making one of these. So thanks for joining me this morning. Have fun measuring the wind. Join us next week for more random acts of science.